All right, so retrosynthetic analysis is something that we've already been looking at. And remember, the idea here is to look at your product and then work backwards. And so some important questions that you're going to want to ask yourself, there's three main questions. The number one question you want to ask yourself is, did the number of carbons change? That's going to point to some kind of acetylide ion or some oxidative cleavage. Did the functional groups change? / move, right? That's going to point to some kind of addition elimination reaction, or if they just changed, maybe some kind of substitution reaction. And then finally, number three is the stereo / regiochemistry of your components, right? Did they add syn with one another? Did they add anti to one another? Did something go in the more or the less substituted position? That kind of thing. So let's go ahead and take a look at an example. And so, right, the number one question we want to ask ourselves is, did the number of carbons change? And so we have 1, 2, 3, 4, 5, 6 carbons here. 1, 2, 3, 4, 5, 6, 7, 8 carbons here. And so the answer is yes, they did change. And so since it increased, we know we have to have some kind of acetylide ion added to some kind of alkyl halide. And so not only do we know it changed, we know it changed by 2 carbons. We have 2 extra carbons. And then if we take a look at the components that we already have an acetylene, right? We already have this triple bond right here. And so what we need is the alkyl halide. So the first thing we've got to do is first deprotonate this to make it a good nucleophile. So we add some strong base over here. That'll make it a strong nucleophile right there. And then the next thing we need to think about is what kind of alkyl halide do we need to add, right? Here we can see we've added 2 carbons, and so we need to add an alkyl halide that has 2 carbons, right? So something like this, right? And then this can undergo an SN2 mechanism. To go something like this, and now we've got 1, 2, 3, 4, 5, 6, 7, 8 carbons there. And so we're a little bit closer. We can ask some more of our questions, right? We've already taken care of the different number of carbons. Now we can think about the functional groups. Do the functional groups change? And the answer here is yes, they changed, but they didn't move, right? We went from an alkyne to an alkene. There's no movement. This is between the 5th and 6th carbon. This is between the 5th and 6th carbon. So we're not moving our functional groups. We're just changing them. And what we underwent here is reduction. Right. So if you think about how we can reduce an alkyne, there's multiple ways. There's hydrogen with platinum, hydrogen with Lindlar's catalyst, or sodium metal in ammonium liquid, right? And so we know that we can use one of those 3 reagents. And then finally, the last question that we want to ask is our stereo / regiochemistry. And we can see that our alkyne here, or our alkene, my bad, our alkene here is cis. So we have a cis alkene. And so we have to go from an alkyne to a cis alkene. So we have to have syn addition of H2. And so this is something that you just have to kind of memorize. That's done with hydrogen and Lindlar's catalyst. And so we can go from this alkyne, add some hydrogen and Lindlar's catalyst to go to this cis alkene. And that's how you want to analyze these problems. Let's go ahead and do a couple extra.